Series versus parallel circuits. Okay, so I'm going to go over the difference in this video. First, the details of which makes each of them different, and then I'm going to go over some helpful tips that I use to remember the difference between each one. Let's first go over E, I, R, and P. If you're not familiar in electrical terms, we're looking at E is voltage, I would be current or amps, R would be resistance or ohms, and P would be power or wattage. If you're confused about why it's called I for current, it's some sort of translation of a word in a different language that means intensity of current. So kind of ridiculous, but think intensity of current. And then E is electromotive force. Okay, so now that we are familiar with that, that'll cause less confusion in this video. So now what's the difference between these when we're looking at the circuit? I like to think of current as the base for remembering each one. So when I think of a series circuit, I first think current. Current always stays the same in a series circuit. Okay, I'm going to go over some tips at the end of this, but here's just the actual basic facts. Current stays the same. As you can see, we see the I total, the current total, would just be I1, resistor 1, resistor 2, and resistor 3's current would all equal the same current going through each resistor. If that doesn't make much sense, think about each resistor. Just think that we're thinking about individual current and voltage for each of these resistors, and the parallel versus series circuit is going to tell us how we're going to math this out, how we're going to figure out the numbers, which formulas we're going to be using. Okay, so furthermore, in a series circuit, if we want to look at voltage of each of these resistors, we're going to be able to add the voltage of each of the separate resistors together to equal the total voltage. Okay, so again, the total voltage is equal to, I'm going to call it E1 plus E2 plus E3. While with current, since it was all the same, the I total was equal to I1 was equal to I2 was equal to I3. They're all equal, okay? All the same, but in voltage you see they add. So it's simply that. If we have different voltages on each of these resistors and we want to know the voltage total, which some people call voltage in, which I wrote in parentheses here, then which could also be E total. So E total, voltage total, same thing. All you do is add the voltages together on each of your resistors. We're only talking about series circuit right now, okay? Then we go into the resistances of each of the resistors. Okay, so that'd be a certain amount of ohms. We would add each of those together to equal the total, just like we did for voltage. So again, our total resistance total is R1 plus R2 plus R3. If there were 3, as we see here, that would equal the R total. Okay? I'm going to go over a simple example at the end of this as well, so we can grasp this and actually see what happened if we had numbers, plug them in. And this is going to be used for my other videos, so I'm going to have videos going over actual circuits, using these formulas and stuff, using this knowledge, so be sure to watch those videos. Okay, now we get into power for a series circuit, and you should know power is going to be the same for series and parallel circuit. Even though we're only talking about series right now, it's the same for both. You just take the power for each of the resistors that you'd have, and you add them together. Just know wattage or power always adds together to create the total, and the number that's going to be changing is going to be the number that you're going to want to use to figure out your answer. So as you can see, I have a constant current, which stays the same. So to find my power, I'm going to have to figure out a number that is changing, which the resistances and the voltage add together. So that's how you'd go about that. I don't want to get too much into that because that'll be for the later videos. This video is supposed to more just be about series versus parallel. So now moving on to the very last sort of tip or thing to talk about. If one of the resistors loses connection and let's say burns out, which is probably what would happen, then they all would in a series circuit. Okay, so let's say you have a bunch of light bulbs wired in series, and you have 10 light bulbs. If your 7th light bulb has a problem, everything goes out. If your 3rd light bulb has a problem, everything goes out. They're all dependent on each other, and you have to have the connection going through each of them for everything to work. Now that takes us to parallel circuits. If we go into a parallel circuit, we can also see what do each of them look like, is a question that I had. Okay, so we can see the visualization of each one. Let's first compare. We were first talking about a series circuit. As we can see, we see the voltage total, or people call voltage in, as I was mentioning, same thing. And we see a circuit. We see resistors, and these are wired in series. And you know they're wired in series because where the conductor's going, you can see the resistor, and then you can see the conductor just goes to each of the resistors from the front of it to the end of it, and they're leading from front to back of each of the resistors. Things are a little different when we look at a parallel circuit, because as you can see, we see our voltage total, or what would be called the voltage in, so the load. And as you can see, when you're looking at the actual circuit, we can see that it's not just the front to back leading to each one, it's actually, you can see the conductor leads to the top of each resistor, and the bottom of each resistor also has its own conductor that takes it back, okay, like a neutral. But we're just going to look at what's going on here in the circuit, and as you can see how it's wired, the resistors are wired differently, okay? And because of this, in a parallel circuit, when one of them goes out, they don't all go out, but we're going to go over that at the end, because of course that was at the end. So let's get into the actual details of what makes a parallel circuit. How can we solve, because it's probably why you're watching this video in the first place. So again, I think about current, okay? And when I think about current, I like to visualize it. When I'm thinking about a series circuit, I'm thinking about each of those circuits wired in series, okay, as you can see right here. And with that, I'm basically thinking about that. Okay, here's my current, and it's going in that straight line, and I'm thinking because of that staying the same, and as it's going to each one, it's a little ridiculous, but that's how I remember it. As it goes to each one, the voltages add together. Okay, so that's just how I remember it. And then things are a little different when you look at a parallel circuit, because instead of the current going in that straight line, which stays the same, that's how I remember it, your current is now a little different. And this is not how it actually works, but this is how I remember it visually. It really helped me. So I like to think of, and remember this is not how it actually works, I like to think of the current in a parallel circuit and visualize the current going like this. Okay? So from the source, it's going out, and I'm thinking as it goes to each of the resistors, it adds. Okay, so from the beginning, this resistor, that adds, because they're in parallel. While when they're in series, I just think one after another, so they're going to be the same thing. It's a little bit ridiculous, but if you come up with a better way to help you remember it, then there you go. But this works really well for me. And it also goes to the fact of process of elimination. So now that I know that I'm in my parallel circuit, and I know that my current is going to be adding, because I'm visualizing my current, that's my basis of thinking about this. My current's going to be adding, okay? So then process of elimination, what does my voltage do? My voltage is going to stay the same, because it's either or. Your voltage is either going to add or it's going to stay the same, and your current is either going to add or stay the same, and they're not going to exist in the same. So as we can see in a series circuit, current stays the same, voltage adds. It's the best way to remember this. Then in a parallel circuit, current adds, but voltage stays the same. Okay? And as I was saying, the visualization helped me remember it. I already went over that, so you can always rewind and watch that again and watch me explain that again. But I'm going to go over the actual formulas, the numbers you'd be using for all this. So if you had a voltage total or an E total, E, you don't have to call it total, but you could call it the E total. Remember, it could also be called the voltage in. So they're going to throw you a lot of things, you're going to have to know each one, and you're going to have to translate into the same thing. So we'll call it a E total, and that's going to equal E1 equals E2 equals E3. Okay, very simple. Whatever one of them equals, all of them equal. What this also means is if you figure out, and this will be in the later videos, one of these, so E1, E2, and E3 are the same. If you figure out one of these, now you know all of them, and you also know the total, since it's the same. It's very helpful knowledge, and it'll help you a lot. Okay, then we look at the current. I already went over that, but we're thinking about visualizing it now. Okay, let's try to think of it fresh every time. We're thinking about a parallel circuit. Okay, so we're thinking about that current adding together in the resistors. Now we know I1 plus I2 plus I3 is going to equal the I total. They add together. Okay, now the resistances are different in a parallel circuit. And I kind of saved this. I didn't really tie this into it, because it's kind of obvious that when you've done this enough, it's a pain in the ass, and you'll remember it after doing it once or twice probably. And what you do for parallel circuits is your resistance total is equal to something kind of interesting. We'll call it 1 over a resistance equal. Okay? And the resistance equal is going to be an equation of 1 over R1 plus 1 over R2 plus 1 over R3, that's going to equal R equal. That is going to be 1 over that number. Okay, I'm going to do a practice example at the end of this to show you. That's where it gets kind of ridiculous. I'll do one of these. We'll see how it's kind of ridiculous. You'll probably remember it, especially if you do it along with me or if you do it after me. It's just kind of ridiculous, and you remember, okay, that's what you do with parallel circuits. And with series circuits, you just add them. I never really had to study that. I think you'll see if you do a few of these, you'll remember it pretty quickly. The main thing to remember is the current and the voltages and how those are different, and process of elimination. So like I was saying, figure out some sort of way to remember it. Last time I'll explain it, visualize the series circuit as each resistor stays the same, so the current stays the same. I shouldn't have said the current in the resistor stays the same, and then at the same time the voltages add together. That's how I visually remember it. And then I go to my parallel circuit, and I think about, okay, my current is going to each resistor, it's adding. That means voltage stays the same. Okay, and again, now we're going to power. Power's the same for parallel or series. So basically, if you know your power for any of your resistors, they're all going to add together to create your total power. They always add together to create your total power, series or parallel, doesn't matter. Okay? And now, we already went over this in the beginning, but again, if one of the resistors now loses connections, which would probably be a burnout, like a light bulb burning out, then the current only stops flowing through that one branch, but the rest work just fine. Okay, so we're going to look back at the actual drawing. And as we can see, let's say these are light bulbs. A light bulb will actually be a resistor. Okay, so each wire serves as a resistor. It's not a video about resistance, so don't want to get into the technicalities of it, but just know a light bulb is going to act as a resistor. So let's think of each of these as light bulbs, okay? And let's say one of them burns out. We'll say the second one burns out, R2, okay? Then what's going to happen is the power is still going to flow through all of them, and just this bulb won't work. Okay, so just the R2, bulb 2 won't work. However, like we talked about in the series circuit, if any of these burn out, let's say R2 burns out in the series circuit, and that's a bulb, they're all burnt out. Because as you can see, the power is going from the front and back of each resistor, and that's how they're getting fed to one another. It's different in the parallel circuit. Okay, so now let's get into a simple example. Okay, so I'm just going to make this simple so I can do a comparison of how the numbers are going to change with series or parallel. So we're going to think of everything as the number 10, and you're going to see how I'm going to do this. Okay, so I'm going to think about each of the resistors, first with a series circuit. If each of the resistors' voltage were 10, we'd have 10, 10, and 10 on each of the resistors. Okay, that's what I mean. That would mean we'd have 10 plus 10 plus 10 in a series circuit, because that's how the voltages they add together. So we'd have 30 total volts. Okay, if each of the resistors had 10 amps, 10, 10, 10, then the total current would be 10 amps. Because the current stays the same in a series circuit, it does not add, doesn't do anything, but stays the same. Okay? That also means if we only knew one of them, let's say R2 was 10 amps, we'd also know the total, but we'd also know R1 and R3's amps because they're all the same. Okay? Then if the resistances were 10 ohms and 10 ohms and 10 ohms on each of these resistors, then we'd add it together. 10 plus 10 plus 10 for series circuit, we'd have 30 amps. Okay, if we had power wattage for each of these resistors, and we had 10, 10, 10, we'd add that together. Our total wattage would be 30 watts. Okay? Now let's go into the parallel circuit. If we had 10, 10, 10 volts for each one, okay, we're in a parallel circuit. So what does it do? Voltage stays the same. Okay, so we'd have 10 total volts, and we'd also have 10 on any of these. Again, that would mean if we only knew R1's voltage was 10, we'd also know R2 and R3 are each 10 volts, and the voltage total is also 10 volts. Okay, the current in a parallel circuit, we have on each of these resistors 10 amps, 10 amps, and 10 amps. Okay, on each of these three. That would mean 10 plus 10 plus 10, we'd have 30 total amps in a parallel circuit. Okay, now this is where things actually get interesting. If we had 10 ohms and then 10 ohms and 10 ohms on each of the resistors in a parallel circuit, well, they're not going to be the same, they're not going to add, but we're going to do that interesting thing that I talked about. Okay, so let's do it. So remember I said 10, 10, 10, so it's good to write it down. These are going to be different most of the time numbers, so it's actually good to write down like R1, R2, so I would do it, and R3. And then from here you can say each of the resistors, let's say different voltage, current, or in this case we're actually doing the resistance. So we can do the ohms. And remember we're saying 10 ohms. Okay, so now I'm labeling each of these 10 ohms. Well, if I was doing current, I'll erase this, but I would say, let's say we're doing the 10 volts, I would also line that up on resistor 1. So I'd say, okay. But now you know which each of them have. Okay, and you can separate them. Maybe even put it like a line if you're doing it quick. Probably will be not as neat on like a test or something. Of course. So remember, we're doing 10, 10, 10. So the formula is kind of interesting. We're going to do 1 over 10 plus 1 over 10 plus 1 over 10. Okay? Now why am I writing out each of those and not just doing multiplication? And that's because each of these is normally different. I'm doing 10 to make this really easy, but normally you won't have each of the resistors the same exact ohms. That's normally not going to happen, or it's the same resistance. So instead of doing 1 over 10, okay, which is, we're going to do on a calculator, we're going to have 0.1. Instead of saying 0.1 times 3, okay? Don't do that. Always formulate the same exact mindset, okay? And the same exact mindset is going to be adding them. Always do the same exact process, because when you get stressed on a test, you don't want to complicate things by trying to save time, and then you end up confusing yourself. That's easily what could happen. So just make it really simple. We're going to add them all together. You can literally see what's going on here. So we're going to do 1 over 10. I'll pull up my calculator so you can see it. And I'm going to do 1 divided by 10. Of course, 1 over 10, 0.1. Okay? So I'm going to do 0.1 plus 0.1 plus 0.1. Of course, in this case, we could do times 3. But like I was saying, I would not recommend that. I would do the same mindset every time. So just do 0.1 plus 0.1 plus 0.1. Obviously, that's 0.3. Okay. But if some other number came up, you'd be like, oh gosh, why? I like to use the calculator. Sometimes you get stressed and you're not thinking in the correct mindset, so it helps. And there we go. So we have 0.3, but remember that this was everything over 1. That's the formula. Okay, 1 over the R equals. So now that we have the R equals, which is this formula, Now we have to do 1 over 0.3. Okay, so now 1 divided by 0.3. And as you can see, we get 3.3 repeating. Write that down, because you're either going to write a lot of 3's, as many 3's as you possibly can, like here, to get closer to your answer, or you might just do one of the 3's, or maybe probably 2 of them to get closer to your accurate answer. It's good to know that, because if you're not getting quite the answer you're looking for, you can fiddle with that. Okay, I don't want to talk about that too much. So now that we have that number, we have that 3.3 repeating, that would be our R total. So as you can see, the question of R total for a parallel circuit can take up a little more time, and that's why on a test it's good to know how to do this so you can do it quickly. But it's also good to be aware of this can take up some more time, so maybe it's something that if you have too many things that you're solving for a bunch of parallel circuits, like a more complex circuit we'll see in a later video, you might not even want to solve that on a test. That might be good in real life to be able to do that, but on a test you might want to skip that, because it'll take so much time that even if you know how to do it, you're going to spend more time than you could be solving other questions and getting a higher percentage on your test. Okay, so now that we went over the resistances, of course the power for the parallel circuit just adds. So add. Now we know as you can see, that took a chunk right there just to explain the total resistance for parallel circuits. So that's what I was saying. You do that one time and you're going to remember that. You're not going to have to study, oh my gosh, that the parallel circuits, you have to do this 1 over the resistance equal, which is 1 over each of them added together. And you'll do it a few times and you won't forget it, okay? Because it's just kind of ridiculous. But that's how you get your answer, and you know that pertains to reality, and that's how we solve the total resistance of a circuit that is wired in parallel. So thank you very much for watching. Now the next videos are actually going to go over real life scenarios of circuits and how we'd actually solve for certain things if we didn't know certain numbers, if we want to solve for certain numbers. Along those lines, you'll see that, and also I'm going to tie in some more complex circuits to where you actually have a mixture of series and parallel circuit in one circuit, and how would you go about solving for that. So check out the next videos for that. Thank you very much for watching. Until next time, take care. Goodbye.